Hello everyone. Last video we are discussing about some universal truth and we are discussing the comparison between the displacement and the distance. In this video we will discuss whether displacement can be zero. That is the first question. Second question, whether distance can be zero for some particular journey I am considering. Now this journey, as we know, O is the initial position and A, B, C are the different position for the different instants. Now, again, first question we will discuss whether displacement can be zero, whether it is possible. Yes, it may be possible. See, again, we will consider one journey. Object has traveled from O to A and back to O. What is the magnitude of displacement for this journey? As we know, distance is a scalar quantity. There, about directions, we are not bothered. But for the displacement, we have to consider the directions. We have to follow some sign convention. So what sign convention we are following? If object is moving towards the right side, it is positive. We have to take the magnitude as a positive. And if it is moving towards the left hand side, we have to take it as a negative. We have to assign these signs to the magnitude values. Now object is traveling from O to A. O to A means it is moving towards right hand side. So that distance with positive sign we have taken. Here we have written positive 60 for OA. And now once it travels from A to O, with respect to A, if I take it, with respect to A, this journey A to O, it is towards the left hand side. So I need to give that distance as a negative sign. So O to A, it is positive 60 and A to O, it is negative 60. If I add them, what answer will come? Displacement will be the zero value. So it is possible that displacement, it is zero. But what about the distance? The distance corresponding to this displacement, if I take, whether it will be zero, whether it will be zero, no. Why? Because for distance, we are not considering the directions. We are bothered just about the path length. O to A, what is the path length? 60. A to O, what is the path length? 60. So 60 plus 60, it is 120. So here, this value or this distance is a non-zero value. Distance value for this particular journey, if I consider, it never be zero. So displacement, it is zero, but distance corresponding to this displacement is not zero. So what same thing I'm saying here. So distance D corresponding to this displacement O to A and A to O journey, what we have considered, for this distance is a non-zero value or it is not equal to zero. Displacement, it is zero. So these are the three universal truths we have to remember. Displacement, it is less than or equal to the distance. Displacement, it is possible, it may be possible that it is zero, but distance, it is always a non-zero quantity, right? Thank you. Hello everyone. In this video, we will discuss regarding uniform motion. So what is uniform motion? Body or object travels equal distances in equal intervals of time. Particular body or object, it is covering equal distance, same amount of distance, and it is covered in equal interval of time. The time duration or time interval is the same, but the distance covered is also the same. Then such kind of motion, we will call it as a uniform motion. One important thing for this uniform motion is the time interval or time duration considered for the motion. Amount of that time duration is very small. Very small magnitude of a time interval is under consideration. Let us take an example. Suppose one fighter plane, we are considering it as an object and it is traveling through an air, and journey of that fighter plane we will consider to understand this uniform motion. So this is the fighter plane. Now suppose when time was 0 second, the distance covered by the fighter plane is 0 meters. Obvious, it has just started the journey. After first second, it has covered a distance of 5 meters. In the next second or second second, additionally 5 meters distance it has covered. So now total distance covered is 10 meters. Then in third second, again additional 5 meters it has covered. Now total distance covered is 15 meters. In the fourth second, again additional 5 meters. So now total distance covered is 20 meters. So this is the journey time and the corresponding distance covered that we will consider now. One important thing for this distance and time relation, what we are observing here, is the distance traveled by that fighter plane. It increases with the time. As time is increasing or time is progressing, the distance covered by the fighter plane that is also increasing with respect to time. Now, if I plot the distance versus time graph, what I will observe is, just for our understanding, we will we will make four time intervals. First time interval will be of 0 second and first second. Second time interval will be of first second and second second. Third will be of second second and third second. And fourth interval will be of third second and fourth second. So these four time intervals we will consider. Our understanding, just for our understanding, we divided the four time intervals as I just told now. One, two, three, four. In these four time intervals we will consider the corresponding distance traveled by that fighter plane. Now let us consider the first time interval. In the first time interval, how much distance it has covered? A distance ds. If you take the values numerically, when duration was 1 second, see here everywhere the duration is 1 second only. Any time interval duration is 1 second only. So for first time interval or a duration of 1 second, distance traveled is ds. Ds is how much here? 5 meters. For the next time interval, if I go again, distance covered is ds. How much it is? 5 meters. For the third time interval, distance covered is how much? ds only, 5 meters. And fourth time interval also, for the duration of 1 second, distance traveled is additional 5 meters. So now, so if I say, so for after first time interval, here this height is 5 meters. From here to here, for the next time interval or second after end for second time interval, the distance from here to here it is 10. Then here distance from here to here it is 15, and here to here it is like 20. So it is like that, it is go on increasing for every duration. Here time duration 1, time interval 1, time interval 2, time interval 3, time interval 4. Time interval what we have considered is 1 second, and every time 1, 2, 3, 4. So ds1, I will say ds1, ds2, ds3, ds4, they are actually the same. Everyone has the same magnitude and its value is how much? 5 meters. Now if I connect the line, that line is passing through the origin of this graph, and this line actually indicates the velocity of that object. So what is velocity, what is speed, what is difference between the velocity and the speed, that we will discuss in coming videos in detail. But here just for understanding, we will say that the distance and time, the line which I am drawing here, this line indicates the velocity of this fighter plane, right? So this kind of motion is a uniform motion. One thing what we observed here is the object has the same or constant velocity. If I take the slope of this line, or if I take the ratio of ds divided by dt, ds divided by dt, if I take the ratio will remains the constant for any time duration or any time interval, irrespective of time interval 1, 2, 3, 4. Any time interval you take, there the ds divided by dt ratio is the same, or the slope of this line is the same. So here that's what we have mentioned, that object or this fighter plane has a same or a constant velocity for this journey from 0 second to 4 second. About this uniform motion, again we will discuss in more depth in coming videos. Thank you. Hello everyone. In last video, we were discussing about uniform motion. We will continue our discussion in this video. So last video we have considered that the time and distance relation, where distance was increasing with the time. Every time there is an additional distance covered by the fighter plane. Now let us consider one example where the distance is not increasing, distance is remaining constant with respect to time. Suppose in between the journey, somewhere in between the journey, I am saying after the first second, the distance traveled by the object is 5 meters. Even in next second also, the distance traveled is 5 meters only. There is no change in distance. Even in third second also, the distance traveled is 5 meters only. There is no additional distance traveled. In fourth second also, it is 5 meters. So irrespective of time, whether it is first second, second second, third second, fourth second, the distance traveled remains the same, 5 meters only. Even in fifth second also, it is the same. Now, as I said, distance remains constant with the time for this journey. Now, if I plot the distance versus time graph, what I will observe is, now again, just for understanding, we will divide the time interval into four parts, one, two, three, four parts. And for four parts or four particular time intervals, if I observe the distance covered and if I plot the lines for this journey, see, for the first time duration or first time interval, how much is the distance traveled? This much is the distance traveled, 5 meters. Now, in the second time interval, how much is the distance traveled? This much is distance traveled. In the third time interval, this much distance traveled. In fourth time interval, this much distance traveled. So, irrespective of the time interval 1, 2, 3, 4, the distance covered by that object, it remains the same. There is no any increase or there is no any decrease in the distance traveled by the object. Distance remains the same. Somewhere here is the first second distance traveled is 5 meters, second 5 meters, third second 5 meters, fourth second 5 meters, fifth second 5 meters. So this distance is constant throughout the journey, or even though the time is increasing or time is progressing, distance traveled by the object is constant. So this kind of motion also we will say as a uniform motion. In this case, we have said that velocity is constant. Velocity here is constant because the ratio of ds divided by dt if I take, or the slope of this line if I take, it is constant. Here velocity is constant. But in this case, velocity is zero. Irrespective of the time duration, velocity, magnitude of the velocity, it is zero. About this graph, we will discuss more in distance time graph and velocity time graph. There, the more clarity of this graph we will get it. But just now for understanding, we will say, just for time's sake, we will say that the distance versus time for these values, if I plot time versus corresponding distance, the value of the distance or magnitude of the distance corresponding to these time intervals, any time interval, the distance covered by the object remains the same. So this kind of motion is also uniform motion, and this kind of motion where the equal distance got covered in equal interval of time. So this is also an example of uniform motion, and this is also an example of uniform motion. We will discuss more about this uniform motion in coming videos. Thank you. Hello everyone. In last video, we have discussed about uniform motion. In this video, we will discuss on non-uniform motion. So what is non-uniform motion? Body or object travels unequal distances in equal intervals of time. In case of a uniform motion, the object has traveled equal distance or same amount of distance in equal interval of time. But in non-uniform motion, the object will cover unequal distances in equal interval of time. That is the difference. Uniform motion, equal distance, but in non-uniform motion, it will cover unequal distance. Let us go with the same example what we have considered for the uniform motion. Let a fighter plane, we are taking it as an object, it is traveling through the air. So this is the fighter plane. Suppose the fighter plane started the journey at 0 second, obviously it has covered a distance of 0 meters. After 1 second, it has covered a distance of 1 meter. After second, it has covered distance of 3 meters. After third second, it has covered distance of 6 meters. And after fourth second, it has covered a distance of 10 meters. Here, if I observe, after first second, how much distance traveled it is actually 1 meter. Then after second, how much distance traveled from first second to second second? 3 minus 1, 3 meters minus 1 meter is equal to 2 meters. After third second, in between second and third second, how much distance it has traveled? 6 minus 3, 3 meters. Then after fourth second, in between third second and fourth second, how much distance it has traveled? 10 minus 6 is equal to 4 meters, right? So here if you see the distance traveled by the object or by this fighter plane, it is increasing in corresponding time intervals. First time interval it has traveled 1, in next time interval it has increased to 2, in third time interval it has increased to 3, in next time interval it has increased to 4. So like that there is increase in the change in distance in the corresponding time interval. In case of uniform motion, these values were constant. Everywhere it was 5 meters. But here, somewhere it is 1, somewhere it is 2, 3, 4. So 1, 2, 3, 4, it is increasing manner. It is increasing manner. So same distance time graph if I plot, for understanding we have divided the time interval same as in uniform motion. And now if I plot the corresponding time interval and the corresponding change in displacement. So there are four time intervals we have considered. Green color we have shown in the time interval and red color shows the actual change in displacement for the corresponding time intervals. So for the first time interval ds1 here is 1 meter. Then for the next time interval 2, ds2 is how much here? 2 meters. Then for the third time interval, what is ds3? 3 meters. Then for the fourth time interval, what is the distance? Change in distance, it is 4 meters. So like this, in this graph also, this ds4 has the highest magnitude, which is 4, and ds1 has the lowest magnitude, which is 1. So it is in increasing order from ds1 to ds2, ds3, ds4. And now if I connect the graph will it will be like this. So this graph is not straight line. It is like curved shape. It is a curvilinear graph, or I will say this graph is non-linear graph. Here what we are observing is the change in the displacement. Change in displacement is it is in increasing manner. This motion is non-uniform motion itself, but to this motion we will give one more name, as this is a increasing non-uniform motion. This is increasing non-uniform motion. And one important thing about non-uniform motion is the object has a variable velocity or changing velocity. Here you can see 1, 2, 3, 4. Everywhere the velocity has changed because change in displacement is not equal everywhere. For every time interval, change in displacement is different. Time interval is the same, but change in displacement or value of this ds is different for each time interval. Here it is 1, here it is 2, here it is 3, here it is 4. So this kind of motion where object has a changing velocity, then that motion we will call it as a non-uniform motion. In case of uniform motion, object will travel equal distance in equal interval of time. But in case of a non-uniform motion, object will travel unequal distances in equal interval of time. That is the big difference between uniform motion and non-uniform motion. About this non-uniform motion, here we have discussed about increasing non-uniform motion. Next video, we will discuss about decreasing non-uniform motion. Thank you. Hello everyone. Last video we have discussed about increasing non-uniform motion. In this video, we will discuss about decreasing non-uniform motion. Mainly the difference between the increasing and decreasing non-uniform motion is we will focus on the change in displacement for the particular time interval. In case of a uniform motion, change in displacement ds and corresponding time interval dt, ds divided by dt. So ds by dt ratio, it has a constant value. Because of that, the curve or the line, it will pass through the origin of the graph. Straight line will pass through the origin of the graph, but in case of a non-uniform motion, as the ratio ds1 divided by dt or ds divided by dt ratio is not constant for corresponding time intervals, there this curve has came. There we will not get a straight line, here we will get the curve for non-uniform motion. And here as the distance ds1, ds2, ds3, ds4, they are increasing in increasing sense. Like here is 1, 2, 3, 4. This graph we will call as increasing non-uniform motion. For the increasing non-uniform motion, we will observe the change in velocity, right? But in case of uniform motion, we will have a same velocity or constant velocity. Now we will discuss on decreasing non-uniform motion. As you can see in this graph, again, for our understanding, we have divided the time interval. Now, for the first time interval, this is the displacement. Then for the second time interval, this is the displacement. For the third time interval, this is the displacement. For the fourth time interval, this is the displacement. And correspondingly for the fifth time interval, corresponding the displacement. So ds1, ds2, ds3, ds4 and ds5 are the displacement corresponding to the time intervals 1, 2, 3, 4, 5. So you can see here, so ds1, ds2, ds3, ds4, ds5 behavior of the displacement if you see. So this ds2 afterwards, the displacement value, they are decreasing. Here they are increasing. So 1, 2, 3, 4, if I see, they are in increasing sense or increasing order. But here after ds2, we can see there is decrease in the displacement. 1 to 2, there is the increase. But after 2 to 3, I will say there is a decrease in the displacement. So to this graph, we will call as a non-uniform motion with a decreasing manner or decreasing non-uniform motion, we will say. So even though this motion or this motion, both are non-uniform motion only, but this motion has a increasing sense or it is in increasing order, and this non-uniform motion, it is in a decreasing order or it has a decreasing sense. Mainly for non-uniform motion, object will travel with a variable velocity or changing velocity. But in case of a uniform motion, object will travel with a constant velocity or a same velocity. Thank you. Hello everyone. In this video, we will discuss about examples of uniform motion. The clock's minute hand operates at a constant speed, covering a certain distance in an hour. So uniform motion, what is the definition of uniform motion? The object travels equal distance in equal interval of time, and for the uniform motion, speed is constant or velocity is constant. Object is traveling with the same velocity. If I consider this clock at home on the wall, this minute hand, this minute hand to complete a duration of 1 hour, it will rotate with some constant speed. This minute hand is rotating with a constant speed to complete 1 hour. Suppose if I consider the tip of this minute hand, and as this minute hand is rotating, so this tip, how much distance it will cover? So if I consider that distance, obviously the distance will be whatever the perimeter of the circle. So proportional to that perimeter, this tip of this minute hand, as it will rotate, it will cover a distance proportionate to the periphery or perimeter distance of this circle. But the thing is, this minute hand, it is rotating at a constant speed. So this is a very good example of a uniform motion. Second is an aeroplane traveling at a constant speed at certain altitude. As we know, when aeroplane, for the three cases, if I consider aeroplane takeoff, aeroplane landing, and when the aeroplane is at a certain height from the ground level or from the sea surface. So for aeroplane takeoff or aeroplane landing, we have to increase the speed or decrease the speed. But once the aeroplane, after traveling through air, once it reaches to a particular height or a certain altitude from the ground or from the sea surface, then after that, that aeroplane travels at a constant speed. It should suppose to travel at the constant speed. The variation in the speed is not allowed for that aeroplane once it has reached that altitude. So traveling with that constant speed is an example of uniform motion. Another example of what we can take is a car traveling at a constant speed along a straight flat road. Again, in case of car also, whenever we are traveling with car, again I will consider three cases. First, the road has a downward slope. That is the first case. Second case, the road has an upward slope. And the third case, that the road is flat. Whenever the road is upward, we have to increase the speed. Whenever the road is downward, we have to control the speed or we have to reduce the speed. Sometimes we need to apply the brakes. But whenever the road is flat, or especially I am saying when we are on highways, we are highway on the highways we will try to keep the speed constant. So generally we will decide that in a 1 hour we have to travel 30-kilometer distance, or 1 hour the car has to travel 40-kilometer distance. So keeping that in mind, we will maintain the speed of the car. So there we are keeping the speed constant of the car, and we are, so that particular motion of the car, we will call it as a uniform motion. So the motion of the minute's hand, it operates at a constant speed, or aeroplane which is traveling at a constant speed at a certain altitude, and the car traveling at a constant speed on a straight flat road. So we are saying about straight flat road, not on the upward slope or downward slope. On the straight flat road, there the car speed is the constant. All these are the perfect examples of uniform motion. In next video, we will discuss examples of non-uniform motion. Thank you. Hello everyone. In last video, we have discussed a few examples of uniform motion. In this video, we will discuss some more examples of non-uniform motion. Earlier, we have discussed on uniform motion. Here, we will discuss on non-uniform motion. So first example is car moving on a crowded street. So as we know, whenever there is some big traffic jam, or whenever you come to the toll plaza, there there are lot of cars will be there, and that time whenever you want to increase the speed of the car or decrease the speed of the car or maintain the speed of the car, it is not decided by you. Whenever you are such a crowded place, your car speed will be decided by the person in front of you who is driving that car. So relative to the others, we have to maintain the car speed, right? Because in a traffic jam or in such a crowded place near to the toll plaza also, so we have to regularly change the speed. Sometimes you have to apply brake, sometimes you have to increase the speed, sometimes you have to decrease the speed, so that the flow which other cars are going, with that flow you have to go. So there actually what we are doing the variation in the speed, and those variations are very sudden. Suddenly you have to increase the speed, suddenly you have to decrease the speed, sometimes you have to apply the brake. So those motions are non-uniform. So car moving on a crowded street, it is a perfect example of a non-uniform motion, because there we are doing a variation in the speed. There we are not maintaining the speed constant. Another example is person jogging in the park. So as you know, whenever we go to the park, and once you are entered in the park, does it happen like that? Once you are entered in the park, you have came for jogging or exercise, and once you are entered in the park, then you have started running, and continuously you are running for 3 to 4 hours, and after 3 to 4 hours you have stopped. And in that 3 to 4 hours running, you are maintaining the speed of 100 kilometer per hour. No, it is not like that. See, simply what will happen, maybe for starting 10 minutes or first half an hour, we will run with some speed. And once we got exhausted, once we got tired, then somewhere we will sit on the bench, we will drink water, we will take a long breath. And after that, once again, once you got feel fresh, then what we will start again our running exercise, or sometime we will walk very slowly, right? So these kinds of variations we will do when we go to the park for exercise or jogging. So there, what motion we are doing, that motion is itself a example of a non-uniform motion. So there, the person went for jogging, exercise in that park. So that person is changing his running speed or his walking speed, right? Suddenly. So there are there is no any constant behavior we are maintaining there. Simply we are changing the speed. Sometime we are increasing, sometime we are decreasing, sometime we are maintaining the speed. So like this much of variations we are doing. So all this is an example of non-uniform motion. There the person or we, what motion, that motion is supposed to be a non-uniform motion. Okay, so the car moving on a crowded street and a person jogging in the park, these are the perfect examples of non-uniform motion. Thank you. Hello everyone. In earlier videos, we have discussed about uniform motion, non-uniform motion, increasing non-uniform motion, decreasing non-uniform motion. In this video, we will discuss about how to measure the rate of motion. So different motions we have studied, but how to measure the rate of those motions, that we will discuss in this video. So we have to measure the rate of motion. So regarding this, I will say there are two terms with using we will measure the rate of the motion. First is speed without direction, and second is speed with direction. First is speed without direction, and second one is speed with direction. Speed with direction is nothing but velocity. In this video, we will discuss about speed without direction, and in coming videos, we will discuss about velocity, that is nothing but speed with direction. So speed without direction or just a speed. What does it mean? When different object take different amount of time to cover a given distance. So it is possible that different objects they need different time or different amount of time to cover the distance. Same distance can be covered by different objects with different time. It is possible. One more important thing here is we are seeing here distance. As we know, distance is a scalar quantity. In scalar quantity, we we are giving importance to only magnitude. We are not bothered about, we are not worried about the direction of that quantity. So in terms of speed without direction itself, we have mentioned here it is without direction. We can write just as a speed also or a speed without direction also. But remember, speed and distance, these are scalar quantities where magnitude has importance, direction has no importance. The time rate at which objects move can be different. So what I have said here, same in a simplified manner we have said here in the second statement, that the object, it can move with different time rate. It may take different time to travel the same distance, right? Let us take an example. Suppose I want to travel from Sanjay home to Yogita home. Sanjay home to Yogita home, and the distance between these two homes, it is 100 kilometer, right? So what are the possible options with which I can go from Sanjay home to Yogita home? So first is with fighter jet or plane, within 2 minutes we can reach this 100-kilometer distance. With aeroplane, same 100-kilometer distance, it will take 20 minutes. If I go with car, it will take 200 minutes. If with cycle, if you go, it will take 2000 minutes. Or by walk, if you go, it will take 20,000 minutes. So these are different objects: fighter jet, aeroplane, car, cycle, walking. These are all different objects, but these different objects, they have taken different amount of time. Here it has taken 2 minutes, here it is 20 minutes, here it is 200 minutes, here it is 2000 minutes, here it is 20,000 minutes. Distance is the same, 100 kilometer. Distance between these two homes, Sanjay home and Yogita home, it is the same 100 kilometer. But these different objects, to cover the same 100 kilometer distance, they have taken different amount of time. So what is actually speed means? Speed is the time rate of distance covered in unit time. In a unit time, how much distance covered, or the time rate. The time rate to cover that distance is nothing but speed. So in terms of this, what travel we have done from Sanjay home to Yogita home, in that case, if I consider this time rate, see here time fighter jet has taken 2 minutes. How much distance we have to travel? 100 kilometer. So simply 100 kilometer divided by 2 minutes. So this distance divided by time if I do, so 100 divided by 2, it is 50 kilometer per minute. Same thing if I calculate for aeroplane, it is 100 divided by this 20 minutes. It is 5 kilometer per minute. Same thing for car. It is 100 kilometer distance divided by 200 minutes. It is 0.5 kilometer per minute. Same for cycle. It is 100 distance divided by 2000 minutes. It is 0.05 kilometer per minute. And same for walk. It is 100 divided by 20,000 minutes. It is 0.005 kilometer per minute. So, in a unit time, fighter jet covers 50 kilometer distance, and if I go by walk, in the same 1 minute, we are covering a lesser amount of distance, which is just 0.005. So here, for these examples, what I can say, the fighter jet or this plane has more speed or has a highest time rate, or speed is more for the fighter jet. Fighter jet is traveling with more speed, and if you go with walk or with the cycle, there it is a lesser speed, less amount of speed the cycle has, and fighter jet here has a more speed, right? So mainly speed, how we will define speed is a ratio of two terms, distance traveled divided by time taken. Remember here we have said distance. Distance and speed are scalar quantities where magnitude has importance. We are not taking consideration in direction. We are not anywhere given importance to direction. So speed is equal to distance divided by time. What unit of speed we can give? See, distance unit is meter, time is in second, so meter per second we can take, or centimeter per second we can take, kilometer per hour we can take, or miles per hour. All these are the units of SI units of the speed. So this is about speed. Speed, it just not a speed, it is speed without direction. So direction we have not considered anywhere. With this speed we can measure the rate of motion. Here we have measured the rate of motion only. Okay, so in coming videos we will discuss about more about this speed without direction term. Thank you. Hello everyone. In this video we will discuss some more terms regarding speed without direction. See, if like a motion, how we have differentiated the motion or different types of motion: uniform motion, non-uniform motion, increasing non-uniform motion, decreasing non-uniform motion. So like that, if I want to differentiate with for the speed, so I can say like there are two types. One is what a uniform speed and other is non-uniform speed. So what is uniform speed and what is non-uniform speed? Non-uniform speed, that we will discuss here. The speed of an object is constant. Speed of an object is constant means that object is under uniform motion. Let us take an example. Now, again, three different cases we will consider. First case is the when the car is traveling on this road. There are three cases. First case is the road has a upward slope. Second, road has a downward slope, and third case is road is flat. So according to these three types, we will change the speed of the car. Whenever there is upward slope, we will increase the speed of the car. Whenever there is a downward slope, we will try to control the speed or try to reduce the speed of the car by applying brakes. And third case is whenever the car is on the flat road, flat surface, that time the car speed we will try to maintain or we will try to keep it constant. So these are three different cases. So in that case, what the third case I said, when the car is on flat surface, the car will travel with the uniform speed or constant speed. That point I am saying the car is under uniform speed or under uniform motion. So we have studied these graphs in earlier videos also. So this graph represents uniform motion itself. For this graph, the distance remains constant with the time, and for this graph, distance increases with respect to time. But here, increase in the displacement divided by the corresponding time interval, that ratio it remains constant. This graph starts from origin, and this graph I will say, this graph starts from 0, but this graph it has a certain distance from this x-axis, right? When time was 0 or particular in between some time journey, here we have some particular distance. But for this graph, the graph starts at origin or 0 point. Both graphs represents the uniform motion itself, but this graph represents distance is constant with respect to time, and this graph indicates the distance is increases with respect to time. Both graphs represent uniform motion only. Now the question is whether the speed of the object is always constant or always uniform. What is the answer to this question? No. The speed of an object need not to be constant. Object will be in non-uniform motion also, right? It is not all the time that speed of the object is constant. Sometimes the speed is not constant. Consider the same car case. Whenever there is upward slope, we will increase the speed. Whenever there is a downward slope, we will reduce the speed. And whenever there is a flat surface, we will try to maintain the speed, or we will try to keep the speed constant. Here, car as an object, if I consider on the road when it is traveling, that time these many variations in the speed, increasing speed, decreasing speed, or maintaining speed constant, applying brake and reducing speed suddenly. So these kinds of things we will experience while driving the car. At that point, I will say the car is in non-uniform motion condition. When the car is running on the flat surface with a constant speed, uniform speed, then this condition will get satisfied. Uniform motion condition will get satisfied. But when we are increasing the speed, decreasing the speed, maintaining speed constant, all three things we are doing togetherly, then that case I will say the car is under a non-uniform motion. We know the non-uniform motion, these graphs also we have studied. So this graph here, the increasing non-uniform motion, this graph represents increasing non-uniform motion, and this graph represents the decreasing non-uniform motion. So same example, the car travels a distance of 100 kilometer in 2 hours. Its average speed is 50 kilometer per hour. See, the car has traveled 100 kilometer in how much time? 2 hours it has traveled. In that case, now we have calculated the speed. But remember, here we have taken the average speed. Average, how we have calculated? Distance 100 kilometer divided by time 2 hours. 100 divided by 250 kilometer per hour. So why to say average speed? Because the car has might not travel the 50 kilometer per hour all the time. It's not compulsory that on the start of the journey, once you start with 50 kilometer per hour, you have to keep the speed constant. No, practically it won't happen like that. Sometimes the car will be, sometimes the car moves at a faster speed, or sometimes it moves at a slower speed. So that variation will be there. So, and an average we are saying that that average can vary from 0 to 50, right? So that average speed we are saying is 50 kilometer per hour. So this kind of motion where the car is increasing speed, decreasing speed, maintaining the speed constant, all variety of combinations of the speeds where we are doing. In that case, we can say the car is under non-uniform motion. So car will be under uniform motion when the speed of the car is maintained constant, and under non-uniform condition when increasing, decreasing, and maintaining speed, all three conditions togetherly done, that time I can say the car is under non-uniform motion. Thank you. Hello everyone. In this video, we'll discuss something more about speed with direction or the term velocity. Velocity we are indicating with the symbol capital V. As we know, velocity is the time rate of displacement covered in a unit time. See, about speed, what we have said, speed is the time rate of distance covered in a unit time. Whenever we are talking about speed, we have to take as a time rate of distance. But whenever we are saying about velocity, we are taking it as a time rate of displacement. See, speed and distance are scalar quantity. There, their magnitude has importance. There is no importance to the direction. But whenever we are saying about velocity and displacement, both are vector quantity. Their magnitude as well as direction both are very important. We know velocity is equal to displacement divided by time. Always remember, here we have taken as a displacement. Velocity and displacement are vector quantity. We are mentioning here displacement means it is with direction and magnitude. So velocity is equal to displacement is s, symbol we have taken s, divided by time is t. So what is the unit of displacement? It is meter. What is unit of time? Time we can measure in second or hours. So SI unit of velocity can be meter per second or kilometer per hour. Now, velocity is the speed of an object moving in a definite or fixed direction. See, velocity is nothing but speed. Velocity is nothing but speed of object only, but that speed is having a certain or a fixed direction. That speed is along with a definite direction. Then we can call that speed as a velocity. So velocity, I will say it is speed only, but the thing is speed has to be mentioned with certain direction, right? So velocity is vector quantity. It requires magnitude and direction both, right? So velocity, displacement are vector quantity. There we should mention magnitude also and direction also. Velocity can be changed by changing the object speed, direction of motion or both. Now suppose certain object is moving with some velocity and now I want to bring change into the velocity. What are the possible ways? What are the possible ways? First way is change the object speed. Second option is change the direction of motion of that object. And third option is combine the option 1 and option 2 and togetherly you perform option 1 and option 2. Means first option is increase or decrease the object speed. Second option is change the direction of the motion. And third option is at a time or togetherly while changing the object speed, you change the direction of motion also. Like that you can perform. Let us take an example. Suppose you are driving a car at a uniform speed of 140 km per hour and you are traveling in a straight path. Remember, I am saying you are driving that car on the road in a straight path, exactly straight path. Your speed is 140 km per hour. And whenever we are saying uniform motion, that means equal distance covered in equal interval of time. Uniform speed means you have maintained that speed or the speed is constant. Now, in this case, if I'm saying it as a uniform speed or uniform velocity, or speed or velocity, both have the same meaning because we are traveling on a straight path, right? But now, suppose if I want to bring change in velocity, now if I want to bring the change in velocity and I want to change the velocity from 140 kilometer per hour to 160 kilometer per hour, I need to bring change in velocity. What should I do? So in that case, what you can do? First option is you have to accelerate the car or you need to retard the car. You press the accelerating pedal and raise the car or increase the speed of the car. That is the first option. Second option, apply brakes and reduce the car speed. This is the first option. Second option is either you change the steering wheel to the left side or to the right side. You can change it to the left side or change it to the right side. It means you are changing the direction of the motion. That is the second option. And third option is togetherly or at a time you are changing the car speed also and giving some direction of, and rotating the steering wheel also. Either you rotate left or either you rotate right. So that rotation or changing the direction, that along with the changing the object speed or car speed, either you are accelerating or either you are retarding. So togetherly if you do, then the change in velocity, to bring the change in the velocity, it is possible. So whenever you want to change the velocity of an object, first thing we need to do is the either you change the object speed, that is the first option. Second, change the direction of motion. And the third, changing of the direction of the motion along with the object speed, that also you can do. So these are the three options with which you can change the velocity of an object. In coming videos, we will discuss about what is uniform velocity and non-uniform velocity. Thank you.